welcome in. So if you're curious about this, it seems almost like a tautology in some sense, but let's try to prove this. So this is the product of three consecutive natural numbers. Okay, so for any n, okay, being natural number, okay, and then you take n+1 and then n+2 and you multiply those three numbers. It turns out that it is always divisible by 3. So in fact, actually, at least one of these, either n+1 or n+2 is going to be divisible by 3. Okay, so let's try to show this. I do want to give you some context, so if you really put numbers to it. So, I mean, natural numbers are 1, 2, 3, 4, 5, and so on. So they're just counting numbers. And what this is saying is if you take three consecutive ones, so for instance, if I would take 1, multiply it by 2, multiply it by 3, so those are three consecutive ones, you can easily see that one of them is always divisible by 3. So in this case, the 3 itself. So it works, for the case that n is equal to 1, okay, where we're starting from 1, 2, and 3. Now, if we move over, so if we take the next 3, so 2 times 3 times 4, so this would be for n is equal to 2, then once again, you can clearly see that this is divisible by 3 because there is a 3 in there. And then you can continue. So you can say 3 times 4 times 5. Again, so there's a 3. So this would have been for n is equal to 3 in here. Now, if we skip over, so now if we go to 4, 5 times 6, okay, then we're kind of back within here. So this is, 6 right there. This would have been for n is equal to 4, so starting there. And 6 is clearly divisible by 3. Now, we can continue this pattern, right? And what we want to show that this is true for any three natural numbers that we would take down the line. Now, we can clearly see that this is true for n is equal to 1. Okay, so this is kind of by the process of induction, which I will use. So you can show for n is equal to 1, well, that is certainly true. Now, you make the assumption, so the second part of the induction is that eventually, okay, we're going to get to some k, all right? So k, okay, multiplied by k plus 1, multiplied by k plus 2, okay? So this is some random k, and this is for n is equal to k, all right? So as we will be going along in here. And now we make the assumption, okay, we assume that one of these is indeed, divisible, so divisible by 3. Okay, so we assume that this is true, and this is the process of induction, that you show the first one, you assume for n is equal to k, and now you want to be able to show that it is also true for n is equal to k plus 1, so for the next item. And if we would do that, well, then what we would get is we would get k plus 1, so that would have been my starting point, multiplied by k plus 2, okay, that's the second one, and then multiplied by k plus 3, all right? And now we want to be able to show that this is indeed divisible, okay, by 3, or at least one of these is. Now, this is not that bad, so, I'll use the little trick of distributing across. So if I take k plus 1 multiplied by k plus 2, okay, so if I take that, I'm going to switch colors so that it's very evident for you. So if I take these two, and then I bring this inside of the bracket over here, so I multiplied by k, so I would get k multiplied by k plus 1, multiplied by k plus 2, and then I bring it in and multiply it by the 3, so I'm going to get plus 3 times k plus 1, and then this is going to be k plus 2. Okay, so that's just factored out. But, okay, hopefully you can notice that this particular term is nothing else but, okay, our assumption that n is equal to k is indeed divisible by 3. So what that means is, okay, so this is divisible by 3, okay, plus this Well, this is clearly divisible by 3 because I have a 3 in here right in front. So if I divide by 3, okay, then it certainly is divisible by 3, and that actually shows that indeed 3 consecutive natural numbers are always divisible by 3, or at least one of them within that pairing of 3, or sorry, within that grouping of 3 will be divisible by 3. So this is actually shown by induction. All right. Now, sometimes what I also want to note is, you can write these consecutive integers, and sometimes you might, be given this question as simply saying, for instance, for some n, the 3 consecutive, okay, natural numbers, could be written out like this, plus 1. Okay, so this is the consecutive n-1, n, and then n+1. This is exactly the same thing. Okay, you can transform it back into, okay, the form, okay, by just simply, let's say letting this equal to some m, okay, and then that's going to result that this right here is going to be n+1, and this is going to be n+2, okay, and then, so this is exactly the same style of problem. So these are 3 consecutive natural numbers, and one of them is always going to be divisible by 3. All right, so that is it. Okay, thanks for watching. Hopefully maybe someone will find this useful. We'll see you in the future. Bye, everybody.